Hi there. This is a video about absolute value equations and inequalities. And what I first want to do is talk about what does absolute value mean and then extend that to the concept of equations and inequalities. So absolute value means the distance from zero, okay? And what we know about distance is that it is always positive, all right? So what we know about the absolute value of a number is that that number is always going to be positive. All right, so let's take a look at something. You've probably seen this before, but I want to do a couple of examples. I want to take the absolute value of 4. All right, and what that means is that the absolute value, and absolute value means these two lines around a number, all right, two vertical lines around a number. That's 4, and then if we were to take the absolute value of -4, we get 4, all right? So usually what we remember is that, whatever we take the absolute value of, we just take whatever's inside and we make that positive, all right? So absolute value of a positive number is positive, absolute value of a negative number is just going to turn it into positive. Now, what we often struggle with is why is that the case, all right? So if we understand the definition of distance from 0, so if I draw a number line, and if I mark +4 on that number line, all right, I want to know what's the absolute value of 4, all right, and what's the distance from 4 to 0, and that's a value of 4. All right, if we do the same thing for -4, and we plot that point, then we're wanting to know what's the distance from -4 to 0, and that distance is also 4. All right, and so that's the idea. That's how we get that. All right, so what I now want to do is I want to take this and I want to write the equation, the absolute value of x is equal to 4. Now, given this is an equation. This is an absolute value equation. If I were to use this concept, use the information up here, what value for x would make this equation true? Meaning, what could I plug into this? Absolute value of what is going to give me a value of 4? And what we notice up here is that you can put 4 inside and -4 inside. So given an absolute value equation like this, what we know, based on that information we just talked about, is that we can split this up and say, well, x could be +4, or x could be equal to -4. All right, and this concept here is what is going to allow us to set up and solve equations for absolute value. Okay, so this is really important that you understand the process of how we got from here all the way down to here, because this is what we're going to use. All right, and so what I want to do at this point is write out a rule. All right, so a rule for solving absolute value equations, okay? And this will work for any absolute value equation. And so if I have the absolute value of x is equal to some number p, then what we do is we set up two different equations. I'm going to take the value on the inside x, set it equal to +p, or take the value inside the absolute value x and set it equal to -p. All right, and this is the exact same thing that I just demonstrated up here. All right, that if I wanted to solve this equation, I would just take what's inside x, set it equal to the positive value, and then set it equal to the negative value. All right, and we solve those equations from there. So let's take a look at an example. All right, so I want to solve this equation here, and what this says is that we have an absolute value of x plus 3 is equal to 7. Now, what I'm going to do is I'm going to split this up into two different equations. I'm going to take x plus 3, whatever's inside my absolute value, set it equal to +7. Or take what's inside my absolute value, x plus 3, and set it equal to -7. And in each of these problems here, I'm going to solve those for x. So I'm going to subtract 3 from both sides, and I get that x is equal to 4, or subtract 3 from both sides here, and we get that x is equal to -10. All right, and so those are the two values that we would get for x if we solve this equation. All right, so just remember that first step. Take your absolute value equation, set it into two different equations, one where you equal to the positive number, one where you equal to the negative number. So now you might have a situation where you have an absolute value equation, but you've got 6 times the absolute value and then minus 1. All right, and so in order to solve this, what we want to do is isolate the absolute value. A lot of people think that you can distribute this 6, but you cannot distribute that 6. Leave that where it is. What I want to do from here is add 1 to both sides. All right, and so we get 6 times the absolute value of 6x minus 2 is equal to 12. All right, then we can divide both sides by 6. All right, so we don't distribute this 6. All right, we want to divide by that number. All right, so then that divides out. We're left with the absolute value of 6x minus 2 is equal to 2. And from here, what we want to do is now we're back at that same step that we were at on that previous example, where now that we've isolated our absolute value, we can split this up into 2 different problems. 6x minus 2 is equal to 2. Or 6x minus 2 equals negative 2. All right, and so we would want to solve each of these. So let's add 2 to both sides here and here, and we get that 6x is equal to, say, 4, divide by 6 on both sides, and so then we get that x is equal to 4 6. Now each of those numbers are divisible by 2, so we can simplify that down into 2/3. All right, in the other one, I want to add 2 to both sides. All right, so we've got then 6x is equal to 0. Divide by 6 on both sides. 0 divided by 6 is going to give us 0. And those are our solutions for a problem like this, okay? Okay, the next example that I want to talk about is where we have special cases. And in a problem like this, where you've got the absolute value of 2x plus 7 is equal to a negative number, what we have to remember is that the absolute value is always positive, all right? So what we can say is that it can't be equal to a negative number. All right. Therefore, if you have the situation where the absolute value is equal to a negative number, you can just come in here and say that this is no solution. All right. You don't have to provide any reasoning, but you just have to remember to look for this and just say that it's no solution. So the next part about this is the concept of absolute value inequalities, all right? And so remember, inequalities are things that are not equal to each other. And what I want to do is I want to put up 2 examples. All right, I want to talk about the absolute value of x is less than 4. And then I want to talk about the absolute value of x is greater than 4. Okay, and so what I want to do is first look at a graph to demonstrate how I'm able to look at these and to solve them. Now what I've done is I've gone into Desmos and I typed in the absolute value of x, which gives you this graph that represents a v, and then I drew the line y equals 4, so this horizontal line here. And what I want to look at is analyze the fact of where does the absolute value of x, where is that graph less than 4? Meaning, where is this graph below 4? All right, so if I look at this part, this here, all right, and then I go, well, it's below the graph between -4 and 4. All right, so what I can do here is I can just solve this and say that x is less than 4 and at the same time is greater than -4. So in between -4 and +4, in between these x values of -4 and +4, we are less than 4, okay? Now, if I look at where is x greater than, absolute value of x greater than 4, all right, I can come in here and say, well, we're greater than 4 on the outside, all right, where we're less than 4 or greater than 4. So if I come in here, I can separate this out and I can say that x can be greater than 4, all right, and that's displaying this part of the graph here where we are larger than 4, and then, or say that x is less than -4, okay? And so that's how I look at that. Now you can also just kind of think intuitively about this. Like, what values could I plug into this absolute value that will be less than 4? Well, if I plug in, say, like 3, all right, and let me show these on the graph. So if I plug in, like, say, 3, 2, 1, 0, negative 1. If I plug each of those x values in into this inequality, they're going to be less than 4. All right, same thing goes here. Like if I plug in, say, like 5, 6, 7, negative 5, negative 6, negative 7, and so on, we're going to get values that are going to be larger than 4. All right, and so that's how you can kind of look at this. All right, but let's talk about a rule. So your general rule, you have two options here. All right, you're going to have the absolute value of x is going to be less than p, all right, or you can have the absolute value of x is greater than p. All right, if you've got this situation where the absolute value of x is less than p, then what you can do is you can separate this out and say that x is less than p and at the same time is greater than negative p, meaning that your value for x is between negative p and p. All right, the other way you can say this is you can say that x is greater than p, all right, on the other one, all right, for this one, x is greater than p, or we write that x is less than negative p, all right? And so these are the rules that we want to use in order to solve any of these kinds of problems. So let's look at some examples. So in a problem like this, where you've got the absolute value of x plus 3 is less than 8, what I want to do is then, drop my absolute value symbol, write x plus 3 is less than 8, but at the same time is greater than negative 8. All right, and we have a compound inequality here. And in order to solve this, all right, if I want to isolate x in the middle, I need to subtract by 3 on all three sides. All right, so that's going to cancel out in the middle. We're left with x is less than and greater than. 8 minus 3 gives us 5, and then negative 8 minus 3 gives us negative 11. All right, if we wanted to graph this on a number line, I'm going to put 0 in the middle, put 5 over here, put negative 11 over here, and we would have open circles, and we would shade in between. All right, and that's how we would solve and graph one of those. Okay, the next example that I want to do is where we have all these operations in and around your absolute value, and we need to isolate the absolute value in order to effectively solve this. So the first thing I want to do is add 5 to both sides. All right, so once we do that, we've then got 4 times the absolute value of 3x minus 2 is greater than 16. Now, a lot of people, again, you'd want to distribute this 4, but you can't do that. All right, what we want to do is divide both sides by 4. All right, and that's going to give us the 4s are going to divide out here. So you've got the absolute value of 3x minus 2 is then greater than 4. All right, because you've got an absolute value that's greater than a number, what we want to do is separate this out into two different inequalities. So 3x minus 2 is greater than 4, or we would take 3x minus 2 and set that less than negative 4, okay? And so we're just following that rule that we had talked about. All right, from here, I want to add 2 to both sides and solve for x. We get 3x is greater than 6. Divide both sides by 3, and then we're going to get that x is greater than 2. All right, on this side, let's add 2 to both sides. So we're going to get that 3x is less than negative 2. Divide both sides by 3, and we get that x is less than negative 2/3. All right, so we've solved that. Let's go ahead and graph this real quick. And so I'm going to draw a number line here. I'm going to put 0 here, put 2 to the right, and then negative 2/3 to the left. I'm going to do open circle here and shade to the left, all right, because we are less than, and then open circle at 2 and shade to the right because we are greater than, all right? All right, let's look at some special cases. One thing that we have to remember is that the absolute value is always positive, okay? And so we have to remember that, all right, because here's why. All right, we could have scenario 1, all right, and I'm just going to give you an example where you've got the absolute value of 3x minus 4 is less than negative 4, all right? And what we have to understand is that this absolute value is always positive. It can't be smaller than a negative number, all right? And so that's the key, all right? So because of that, this would be no solution. All right, now the flip side is is that let's say you have an example here where you've got the absolute value of 3x minus 4 is greater than negative 4. And what we realize is that since this is always going to be positive, a positive number is always larger than a negative. All right, so because this is larger than a negative, this is going to have all real numbers as your solution. All right, you can write all real numbers or you can write infinite solutions. All right, and that's the idea. So hopefully this all makes sense. Please reach out if you have any questions, and we'll talk to you guys soon. Thanks. Bye.